Today we are continuing our tutorial. That is a tutorial on topic called probability. Probability. What is probability in general? When we talk of probability, let me give you brief information about it. Assuming we have about, let's say, 6 girls, and then 7 boys in a particular class. That will give us a total of what? 13 students, assuming they are students, 13 students. So if I want to find probability of, if a student is to be picked or selected at random, what is the probability that a person is a girl? Then here, the total is going to be what? 13. So probability of picking a girl will be 6 over the total 13. The probability of picking a boy is what? Is 7 over that 13. That's what I'm talking about. Exactly. Okay, now, before we move on, I want us to understand, but I'm reminding you to subscribe to Calendar Man Television, Calendar Man TV, so that you can get more update of that. And let me remind you that anytime you subscribe to the Calendar, just type Calendar Man TV on YouTube. Then you subscribe, you just click on subscribe, and after you clicking on the subscribe, then you have to click on the notification bell as well. If you don't do that, then you are not going to get all the updates anytime I do the posting. So, to make probability easier for us, we want to look at certain fundamental definitions of probability in your short. We have a trial, your probability. So, definition of terms in probability. So the first term is trial. What is a trial? It says that a trial is any process which, when repeated, generates set of results or observations. Example, tossing a coin or throwing a die. What am I talking about? If I want to try, like I have a coin and I toss it once, and I look at it, I got a tail, I toss it again, I got a head, whatever it is. Then the process that I'm going through is called a trial. Try your luck. You don't try. You understand? You try and see. And after you do that, then of course you'll be getting series of observations. Let's say I have a die and I throw it. I try it. In the process of throwing the die, I am trying my best. And what did I get? What I get is what we call the outcome, which is the next term to talk about. So, example, tossing a coin or throwing a die. Then the second term is outcome. What is an outcome? An outcome is a result of performing a trial. After you perform a trial, what comes out? If I have a die and I throw it, and then I'm looking at it, I got 6. Then the 6 is the outcome. Is that okay? Whatever a man does, there is an outcome to what a man do or does. Is that okay? So we say that example is what? Example, to note a head when tossing a coin. Okay, that's what we are talking about. This one is very straightforward. Then we call something the sample space. So we have spoken about an outcome. When we say an outcome is a result of performing what? A trial. So what comes out of the trial is the outcome. Okay. Then the sample space. The sample space. What is the sample space? The sample space is the what? Is the complete set of possible outcomes. For example, if I want to throw a die, okay, a die, what are the possible numbers that will come out from the die? You know, the die we have 1, 2, 3, 4, 5, and 6. These are the possible outcomes for a die. I haven't seen anybody who is throwing a die and say, I got 0 millibu or 7 millibu. No. This is the universal set for the die. So you either get 1, 2, 3, 4, 5, or 6. So that's what we call the sample space. If I'm throwing a coin, then the sample space is either a head or a tail, or a head and a tail. I hope I've made my point. Then, let's try to get this fundamental aspect as well. You want to know what an even number is. What is an even number? Even number. An even number, or even numbers are numbers that are divisible by 2. Even numbers are divisible by 2. I mean, when you divide that number by 2, there's no remainder. So what are even numbers? So even numbers, okay? are what? We have 2, 4, 6, 8, 10, 12, and so on and so forth. It's like 2, 1, 2. As the kids used to say. 2, 2, 4. These are the evening numbers. Even numbers. When you divide that number by 2, there is no remainder. So what are other even numbers you can mention? One can mention 20, one can mention 50. But you can't mention 71. Why? Because when you divide 71 by 2, there will be a remainder of 1. So take note of that. So even numbers are numbers that are divisible by what? 2. Then we talk of odd numbers. Odd what? Numbers. What are odd numbers? It says odd numbers are numbers that leave a remainder of 1 when divided by 2. So what are odd numbers? Odd numbers, we have what? Sorry. 1, 3, 5, 7, 9, 11, and so on and so forth. That is when you divide that number by 2, you get a remainder of 1. So what are other odd numbers you can see? 27 is an odd number. 31 is an odd number. But 50 is not an odd number, it's an even number. Because when you divide 50 by 2, there wouldn't be any remainder. I hope that is also clear. Now, as you progress, there is one aspect or one definition that actually people get confused about. And that's the prime what? Number. Prime numbers have only 2 factors. That's the number itself and what? And 1. So examples are what? 2, 3, 4, 2, 3, 5, 7. You can't go to 9. I can go to 11, 13. I can't go to 15 unless 17. Okay? Then 19. I can't go to 21. I'll tell you why. I'll go to 23. I can't go to 25. I can't go to 27 unless 29. Why am I saying I can't go to? For instance, 9. 9 is what? 9 is an odd number, but it's not a prime number. Because, let's take the 2 for example. 2 has only 2 factors. That is, the number itself, 2 and 1. 3 has only 2 factors. That is 3 and 1. 5 has only 2 factors. That is 5 and 1. Apart from 1, no other number can go into it. That's what I'm saying. So 2, even though it's an even number, it's a prime number. But 1 is not a prime number. Why? Why is 1 not a prime number? 1 is not a prime number because it has only 1 factor. But we need 2 factors. The number itself and 1. Are you getting the point? So you can't go to 15 because 15, you can get 1 can go into it, 3 can go into it, 5 can go into it. So it has more than even 3 factors. That is how we detect the prime number. So fundamentally, let me give you this few. 2, 3, 5, 7, 11, I omitted 9 because 9 is not a prime number. 13, 17, I didn't write 15 or 15 is not a prime number, okay, because it has more than 2 factors, okay. Now, then we have something called the perfect squares. Perfect what? Squares. In fact, it is very, very important, and I'm reminding you to subscribe to Calendar Man Television because there are more updates that are coming your way. Is that okay? So we talk about perfect what? Perfect squares or square. Okay, what are perfect squares? Perfect squares. Perfect squares are numbers with perfect square root. For example, perfect squares are 1, 4, 9, 16, 25, 36, and so on and so forth. That means if I find square root of 1, I'll get 1, no remainder. If I find square root of 4, I'll get 2, right? Square root of 9, I get 3. Square root of 16, I get 4. Square root of 25, I get 5. Square root of 36, I get 6. Have you seen the trend? Now, how do we generate these numbers? If for you to remember, how do you generate these numbers? There is a trick. If I want to generate perfect squares, I'll just say that. We have the counting numbers, which is 1, 2, 3, 4 in that order. So if I want to generate the first perfect square, I'll say 1 times 1, it will give me 1, which is here. 2 times 2, it is equal to what? 4. Next number is what? 3. 3 times 3 is what? 9. 4 times 4. 16. Have you seen the numbers are coming? So you can use that to generate your perfect squares. Okay? You can generate it to millions of numbers. 5 times 5, 25, 6 times 30, 7 times 7, 49, 8 times 8, 64, 9 times 9, 81, 10 times 10, 100, okay, 11, 121, so on and so forth. So that is how perfect squares are generated. So I'm repeating, what is a perfect square? A perfect square is a square or a number which has perfect square root. 8 is not a perfect square. Why? Because when there's no number that will give you exactly that can multiply itself to give you the 8. But there is a number that can multiply itself to give you 4, which is what? 2. There's a number that can multiply itself to give you 25. So they are perfect squares. We have perfect cubes. Perfect cubes are numbers. I've spoken about perfect square, okay? So we are moving to perfect cubes. What are the numbers? In the same way, I have 1, 8, 27, 64, and so on and so forth, 125. Once again, how do you get that? And what is the meaning of that? It means there is a number which, when you multiply it 3 times, let's say that number times that number times that number will give you 8. What's that? It is 2. There's a number which, when you multiply by itself 3 times, it will give you 27. So how do you generate the perfect cubes? I have 1 times 1 times 1 will give you 1, which is here. 2 times 2 times 2 will give you 8, which is here. 3 times 3 times 3 will give you 27, and so on and so forth. So that's how we generate perfect what cubes exactly. Now, so let's talk about multiple of what? Numbers. What are multiples of numbers? It's just times. So let's say multiples of 6 means 6 times. 6, 1, 6. 6 to 12. That's the multiple of what? Of numbers. Are you getting it? It's very simple. So let's say multiples of 3 will be what? Multiples of 3 will be what? Will be 3, 6, 9, 12, 15, and so on and so forth. That will just multiply the number. If I want to generate multiples of 3, then the first multiple will be obtained by saying 3 times 1, which is equal to 3. 3 times 2 is equal to 6. 3 times 3, which is equal to what? 9. In that order, exactly. You can generate the perfect multiples of numbers. So let me ask you, how do you generate multiples of 20? It is 20, 40, 60, 80, 100, and so on and so forth. Multiples of 7 will be what? 7, 14, 21, 28, 35, and so on and so forth. So I guess I've made my point, okay? So that is multiple of numbers. Then we have factors of numbers. Factors of numbers. This is where one has to be very careful because you'll be doing what we call the algebraic expressions, and the factors will come in again. So factors of numbers, they are numbers which can go into that number without remainder. So for example, factors of what? 20. What are the factors of 20? Sometimes it is very difficult for you to know, but I'm going to show you a simple trick. Factors of 20. Okay, they are 1, 2, 4, 5, 10, and 20. Okay. Now, I'm going to show you a trick of generating factors of numbers. So let's see how we got the factors of 20. We have counting numbers. The counting numbers are what? 1, 2, 3, 4, 5, and so on and so forth. So look at how I'm going to generate the factors to get these numbers. The number in question is 20. So first step is 20 over 1 is equal to what? 20. Exactly. 20 over 1 is equal to 20. So I will just write what I used to divide, which is what? 1, 20. I write what I used to divide, then the result. Then I move to next factors. Next 2 factors. That will multiply to give you 20. So I'll write 20 again. 20 over 2, right? From where I move to 2. It will give you what? 10. Please watch it carefully. 20 over 2 is equal to 10. So in this regard, I write the 2 down here. 2 here, then I write what? 10. I'm expecting the next factors to be between this one. Now, 20 over 3 will give you 6.6 something something. So it means that cannot whole. The moment you divide and there's a remainder, you have to move on. So 3 will give you a remainder. I don't want to remember. So 20 over 4 will be equal to what? 5. So I have what? 4 here, 5 there. Exactly. Now watch here. That's your mind here. So now, what are the numbers? So I'm going this way. So I have 1, 2, 4, 5, 10, and what? And 20. That's how I've derivated my factors of 20. This is very important because we shall be using this when we deal with the quadratics. Tell your brothers, your friends and sisters and whoever to subscribe to Calendar Man TV. Okay, subscribe to Calendar Man TV. Go to YouTube and subscribe because more updates will be coming your way. I want us to look at another interesting factors of numbers. So let me use a number like, let me try this 72. Then I will go to a longer range. 72, the first one is 1 and 72 automatically, right? 1 and 72. So next one is what? 72 over 2 will be what? 36. So I write 2 and 36. 72 over 3 will be equal to what? Will be equal to, I think, 24. Are you getting the point? So I write 3, 24. You see that it is closing. 72 over 4 will be what? I think 18. Okay. So I have 4 and 18. 72, when you divide it by 5, there will be remainder. So let's see, 72 over 6 will be 12, right? So I'll write 6 and 12. This 6 and 12. 72, 7 cannot go into 8. What about 8? Yes, 8 can go into 8. So 72 over 8 is equal to 9. Exactly. So we have 8 and what? 9. Exactly. Now look at what I've got. So you see that as we come, it draws closer and closer. Take note of this very well because when you read quadratics, we are going to apply the same principle in head. So factors of 72 are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72 itself. I guess I've made my point. Just follow these 2 steps and you can be working more of them. Exactly. Now, at this juncture, having known all these aspects we are talking about, you want to start solving problems. So, problem number 1, or case 1, look at how you're going to do about it. The case 1. It says, case 1. So, it says identical objects with different characteristics. Now, problem 1. A basket contains 8 blue. 8 what? Blue. So, number of blue. Where B represents the blue. So you can let B represent blue, that kind of preamble. Okay. Then, number of blue balls is equal to what? Is equal to 8. Number of green balls, engine, is equal to 6. Then number of yellow balls, n yellow, is equal to 5. So n total number of balls in the basket is going to be what? 19. Exactly. Meanwhile, you let the examiner know that let B represent what? Blue. Do that. G represent green, and then Y represent yellow. Let the examiner know that so that anytime you quote G, B, something, he knows what you are talking about. Okay. Now, so he said, if a ball is to be picked at random, what's the probability that it is what? It is I, green. So, P, green. That probability of getting a blue ball will be N, green over N what? Total. That's the meaning. Probability of getting a blue ball from the total is N, green. So we have 6 over 19. Okay, so that's all. That's the probability of getting green ball. Then this is the I. I'm repeating. Number of blue balls were 8. Number of green were 6. Number of yellow were 5. So after you do that, then sum all of them up. And when we sum up, we got 19. So probability of getting blue is what? The total, the blue, number of blue over 19. Probability of getting green is number of green over 19. Probability of getting yellow is number of yellow over 19. Exactly. So let's see. So it says P B. That is probability of getting blue. Will be what? Will be NB over NT. Exactly. NB NT. And what is NB? NB is 8 and N total is what? 19. Exactly. Then I think the I. It says what is it? What is it? I. It says P green or what? Or yellow. Yellow. There are certain aspects I didn't give you in the introductory aspect, but as we progress, I will let you know. For example, in probability, when you see or, it means it's plus. So over here we have two ways of solving this. So it is going to be what? It's going to be Nj plus Ny. Number of green plus number of yellow. All over number total. Exactly. What's the number green? Number of green is 6. Plus number of yellow is 5. All over 19. So that will be 11 over 19. So probability of getting green or yellow is what? Is 11 over 19. In fact, another person can do it this way. He will just say that P green plus P yellow. In that case, what is P green? It is 6 over 19 plus 5 over 19. When you work it out, we are still going to get 11 over 19. It's the same procedure exactly. Then it says neither green nor blue. So if it is neither green nor blue, it is what? It is yellow. So how do you do it? You can add green and blue. That will give you what? Green and blue. What is N green? N green is 6. N yellow is what? Is 5. So you add this to this. Then you get to 11. Then you subtract 11 from the 19. That will be what? 8. And it is here. If it is not green or yellow, then it is blue. So N in this case, P blue is going to be what? It's going to be 8 over the 19. Exactly. Now, I hope I can proceed to problem 2. Problem 2. Let's see what that one reads. I think probability we have a long way to go. We are solving about 19 or 20%. So at a certain point in time, some of them I may leave them for you to go and try your hands on. He said that out of 7 students in a class, there are 3 boys. Out of 7 students in a class, it means over here, problem 2, NB is equal to 3. Then N total is what? 7. So the rest will be what? Of course, they will be guessed, which is 4. And they are asking that if a student is to pick at random, what is the probability that that student is a girl? It's straight away. So PG is what? Is 4 over the total, which is 7. That's all. Yeah, we don't waste time too much. Now let's move to, are you okay? In the class, number of boys is 3. Number total is 7. So number of girls, you subtract the boys from the girls, the total, that will give you 4. So probability of getting a boy is what? Is 4 over 7. Now let's look at a very interesting aspect. This one, you have to be very careful about this type of question. But I'm reminding you to subscribe to the Calendar Man television, exactly, the Calendar Man TV. Okay, it is very, very important. Go to YouTube, subscribe, share it to your friends, and we are dealing with more. We'll be dealing with construction, we'll be dealing with almighty plane geometry and other topics that are actually disturbing you. Mensuration, and I will deal with all of them. And here is a mathematics classroom. Of course, you have to take note. You can learn from here straight away, write examination and pass. Yes, trust me and trust God for that. Exactly. That's it. So let's see. Problem 3 in your shot. He said that a basket contains 5 ripe, okay, 5 ripe and 7 unripe oranges. 5 ripe and 7 unripe what? Oranges. In the same basket are 10 ripe and 3 unripe apples. If a fruit is to be picked at random, what's the probability that it is an apple? It is ripe. Blah blah blah. Now let's look at the structure of this question. The data here is different. A basket, so over here, you have to make a table. It normally appears in examination so well. So be very careful about it and note as such. Is that okay? Now, let's take our time and read it again. A basket contains 7 ripe, okay, oranges. And in the same basket you have what? So he has mentioned oranges and apple. That's the fruit, okay. So you have to write orange, okay, and what? And apple, okay. Look at it carefully. He has mentioned orange and apple, and then he has mentioned something to qualify. What's the name? The adjective, okay. And he says ripe and unripe. So ripe and unripe. I hope I've made my point. I'm saying that such a person, he mentions a particular thing that has common characteristics. He mentioned orange and apple. Then he mentioned ripe and unripe. So we are now going to put them inside. So he said that contains 5 ripe oranges. So this is oranges ripe, 5. You put your hand on orange and put your hand on ripe. And then 9 unripe orange, so 9 unripe. You see it. In the same basket are 10 ripe apples. So ripe apple 10. And then what? And then 3 unripe apples. So here is 3. When you do this, you are almost done. Okay. Now let's see. I'm going to do some addition. Right side I have 15. Exactly. Then unripe I have what? Unripe I have what? Look at here. Look at the unripe color. What do I have? It's 12. Exactly. Then you write. Happen to turn this way also. Oranges will give you what? 14. Then apples will be what? 13. Now it will surprise you that look at how I did it. Total here, total here, total here, total here. Now, so when you add this to this, you get 27. And you add here to you get what? 27. When you cross check and it is not so, then it means you are wrong. After getting this, then any question he asks you is very, very straightforward. Now let's see. He says probability of getting, so right now, M total of the fruit is your 27, which has been confirmed here. Now he's asking you probability of getting an apple. So P apple is equal to number of apples. How many apples are we having? Number of apples. Total number of apples is what? Is 13 over 27. Exactly. Total number of apples is what? 13. And then the total is 27. Then II. P ripe. So the P ripe, you look at the ripe, fruit. Here we didn't mention already, but I said ripe. So if it is ripe, it means the ripe. Well, the ripe is here. Ripe orange plus ripe apple. So P ripe is going to be what? It is going to be N ripe over N total. Is that okay? And what's the number ripe? Number ripe is 15 over 27. Of course, there could be some cancellation here. 5 can go into this one, 3. 3 can go here, 5. It can go here, 9. Okay. Now, then he says, I hope you are getting it. He says an apple, a ripe apple or unripe mango. So he says a ripe apple or unripe orange. So it will be N ripe what? N ripe apple plus N ripe orange all over N total. That's what I can say. N ripe, but it says P ripe apple or unripe mango. Orange, sorry. So here, what is ripe apple? So ripe apple is 10 plus P ripe apple or unripe, sorry, or unripe orange. What is unripe orange? Unripe orange is 9, so plus 9. 13 over 27, is that okay? So basically that is what happens over there. So take note. Now, we are moving to problem 4. We are moving to problem 4. Problem 4, still under the same type of question. He said that, subscribe to Canada Man TV and enjoy this. There is a very powerful table here, which has been sometimes in the examination they do it that way. This is the table, this is how the table looks like. Let's draw it quickly. I have a table like this with 1, 2, 3, 4. Then here, 1, 2, 4, like this, okay? Then it says here is Benz, Toyota, then Opel, these are cars. They say here is black, red, and white. These are brand of cars, and they are respective colors. And the figures are captured accordingly. So 21 here, 13, and then here is 5. Then here we have 9, 14, 6. Then here we have 16, 8, and 2. Now, and they are going to ask us some questions. So you have to do something. Here, these are colors, these are the brands. So here, let us quickly do the addition. Here, I think here will be 34. So 39, right? 39. What about here? 23, 29. Yeah, what about here? 24, 26, okay? Then you do the total this way. This and this is 30, 46. I'm doing the totals. Here is 27, 35, okay? Then here is what? 11, 13. Now, interestingly, when you sum up from here, 39 plus 29. So let me do the addition quickly. 39 plus 29 plus 26. Here is 18, 4. 24. So 4, remember 2. So here is what? 5. 5 plus 4 is 9. 94. Okay. So here is 94. Total is 94. And when you add this one also, you should be able to get the same. Let me repeat for the second time. This is 18, 24, 4, remember 2. Here is 5, 9. So 94 is correct. So the total number here, when you add the total here and here, you have to get the same thing. So now let's see the question that they are asking us. It says that probability of getting a red. So P red is equal to N red over NT. And what is red? So we have 29 over 94. Okay. Then it says a Toyota. P Toyota will be N Toyota over N total. So what is N Toyota? Normal Toyota is 35. So 35 over 94. Is that okay? Then it says neither Toyota nor Benz. If it is neither Toyota nor Benz, then it is what? It is Opel. I'm repeating. Neither Toyota nor Benz, then it means it's going to be P Opel. There are 3. So if it is not Toyota, then it is Opel. So that will be 13 over 94. Is that okay? Then Opel. It says Opel once again. Then Opel is the same thing. Okay. Now, there's problem 5, where it's also following the same line. I hope you've gotten this one. Here there were brand of cars and then their colors. I added here, do that. Then we say the total is whatever he asks you. For example, when he asks you that what is the probability that it is white, what do you do? The white is what? 26 over the total. What probability that it is red? Total red is 29. While the red constitutes what? Benz, red Toyota, red Opel over the total. I think it's very simple, right? You should be able to understand it. Now, problem 5. That one you speed up a little because I guess you've understood this one. A household consists of 7 males and 8 females. Okay, children. So here once again, he has mentioned adult and children. So here is children, and here is what? Adult. Then here is what? Male, female. Here we speed up a little bit, okay? Because you've now understood. He said in a household consists of 7 males, 7 male children. So male children, they are what? 7. And 8 females children. So here is 8. In the same household are 10 male adults. When you read it, 10 male adults. So adult male is 10. Then what? 9 female adults. Here is 9. So once again, here is 17, right? Here is also, I think, okay, 17. Okay, that is how it is. So we add here becomes 15. Here becomes what? 19. And when you sum up, you get 34. So he began to ask you a series of questions. Probability of getting a female child. So P, female what? Child. What is female child here? Female child. Female child is 8. So it is what? 8 over 34. That will be 4 over 17. Female child. Because we know our total amount. It says either a male child or female adult. So male child or female child. What is male child? Male child is 7. Then female adult is what? It's 9. All over 34. And that will be 16 over 34, giving you 8 over 17. Is that okay? Is that okay? And it says a male adult. What is the male adult? Adult, male. So it is 10 over the 34. When you cancel, it's going to be what? 5 over 17. Okay, this one I will not even work it, I'm just mentioning it. Then an adult. Where is an adult? This is the total for adult. Adult is 19, so 19 over 34. Okay. A child. A child is, total child is what? 15 over 34. Then not a child. If it's not a child, then it's an adult. So it is adult is 19 over 34. Are you getting the point? So first, just add this one, this one. Sometimes in examination, they'll give you all the necessary information you put in. But if they don't give you, study the person and note that you see that it follows certain common characteristics. Let's say you mention some fruit, 2 fruits, then you mention whether they are ripe or unripe, that kind of thing. Look at it carefully and you'll be able to handle it easily.